This is Lab 23 for Honors Chemistry, Molar Volume of a Gas. Please note that we are skipping Lab 22, Charles' Law. So if that's the lab you're looking at, set it aside and go on to Lab 23, Molar Volume of a Gas. So most of you in class have seen what a eudiometer is. This little picture off to the right and the top of your lab is kind of highlighting what a eudiometer looks like when you hold it. It's like a giant test tube, but it has graduated markings on it so that we can measure an exact amount of gas. And that's exactly what we're going to do in this lab, where we're going to generate a certain amount of hydrogen gas through the reaction of magnesium with some hydrochloric acid in a single replacement reaction. And we're going to produce that hydrogen gas so that we can measure it at the top of your eudiometer. Now, the idea is that this is water displacement, just like Lab 21 was. So the procedure is generally the same. It's just that we're going to have all of the reaction take place within the eudiometer itself. Your materials are here. You're going to need, as I said, hydrochloric acid. It's going to be 6 molar hydrochloric acid. It's pretty strong, just as we used in the last lab. If you spill it, let me know so I can help you clean it up safely. So the purpose of this lab is to collect the gas, the hydrogen gas, and to measure its characteristics, its properties, its volume, its temperature, and its pressure, and to decide, using those measurements, to do a little calculating and figure if we can replicate this idea of molar volume. If you think back to our last unit when we did moles and stoichiometry, there is a set amount of space that any gas, 1 mole of any gas at standard conditions, occupies. That volume, in theory, is 22.4 liters. Now, we're not going to create 22.4 liters in this lab of the hydrogen. That would be an excessively large amount, but we can create a smaller amount of gas in lab and use some fancy calculating to figure out what volume it would be if we were working at standard conditions, because nobody wants to work in STP conditions. Nobody wants to be outside at this time of year and working, because that's what you would have to do. So, to get started here, let me highlight some common pitfalls. You want to make sure that you measure the length of the magnesium ribbon. I am going to give you another mass measurement from which you can calculate the mass of your particular piece of magnesium ribbon. But you're going to need some length measurements first in order to do that calculating. 10 milliliters of hydrochloric acid that you see in step 2. This can be measured directly in the eudiometer. You do not need a graduated cylinder. You can measure it right in the eudiometer. And it does not have to be exact. 10 milliliters, if you have 9, that's fine. If you have 11, that's fine too. We just don't need much more than 10 milliliters. You're going to then top off the eudiometer with tap water. Now that tap water is going to be in beakers sitting out on the counter. Do not take it directly from the tap. If you bring it from the tap directly, it will be too cold, and that will mess with our temperature readings. We want to keep everything about at room temperature. So I have set out some beakers on your lab tables that have water that has been sitting out and is currently at room temperature. I'm going to have to take that measurement of room temperature, and I will record it on the board for you. So this measurement here, 1 meter of magnesium ribbon, room temperature, and atmospheric pressure, I will have on the front board in the class for you. You do not need to make those measurements because they are the same for everyone doing the lab. You're going to, once you fill your eudiometer with the tap water completely, place the magnesium strip in, insert the stopper. The stopper that I'm talking about here, it has a single hole in it, so that as you collect the gas, the water and the hydrochloric acid will be pushed out into the collecting beaker of water, into a smaller 400 milliliter. I think that's the size we'll put out for you, 400 milliliter beaker, and you will have that available to you at your lab station. You're going to let the magnesium react with the acid, and when it is complete, you're going to take the entire setup, the beaker, the eudiometer to the demonstration table, and there we're going to have a large graduated cylinder. It's going to be one of our Mac Daddy graduated cylinders, the 1,000 milliliter. That too will have water in it, and you are going to be transferring your eudiometer upside down with a little bit of water and a bunch of hydrogen gas. You're going to transfer that over with your finger over the opening here, because we don't want to let any of that gas out. And we're going to transfer that over to the 1,000 milliliter beaker or graduated cylinder, and I'll show you how to read that when we do. At that point, cleanup is super simple. You're going to rinse out the eudiometer. It should all be just an aqueous solution and gas that's left in the eudiometer. You're going to dump that in the sink, rinse it out, and return everything, all of your equipment, where it came from. From then on, you are set to do some calculating, and that's what we will do. We'll start together. We'll have time to do that in lab, and you can finish on your own. Good luck!